All right, welcome back to our Chapter 2.3 video lecture series. And this is the previous slide we looked at. Okay, so we went over the 5-number summary in the last video. That includes the minimum, first quartile, median, third quartile, and maximum. And if we have this information this is self-reported study hours by students, min 2 hours, max 69 hours, and 10, 15, 20 for the 3 middle quartiles. The distribution of number of hours spent studying each week. If you just know this information, would you think it's symmetric, right skewed, left skewed, or impossible to tell with this information? Might be a little bit trickier to see here, but this is going to likely be a right skewed distribution. And one way to tell with that is notice here the first quartile, the median, and the third quartile are all 5 hours apart. They're fairly evenly distributed. The min is 8 hours less than the first quartile. But notice here, there's a big outlier on this max number of hours studied per week. It goes up to 49 more hours from the third quartile. So that right here, that's distributed right here, the 69 hours. So this median, it's saying right here, the bulk right here, this is 25% of the responses basically is less than 10. Half of the responses are less than 15. And this says 75% of the responses are less than 20. But we get kind of this right tail, right distribution that you could see kind of from that max. The max is so much bigger than the rest of the 5-number summary. All right, other measures of spread are the range. That's just the max minus the min. And you should include outliers. In the range, outliers should be included. The interquartile range, IQR, is the difference between the middle 2 quartiles, Q3 minus Q1. All right, is the range resistant to outliers? Hopefully you see that that's no. The range depends entirely on the most extreme out values. So if you have outliers, they will be calculated in the mean, the max, and the min. Is the IQR resistant to outliers? The answer for this is yes. The IQR is based off the middle 50% of the data, which will not contain outliers. So as a quick summary, comparing all these statistics from the last 2 sections, measures of center, the mean is, we would say it's sensitive or not resistant to outliers, but the median is resistant. For measures of spread, standard deviation is not resistant. We haven't looked at an example of this, but I've got an in-class worksheet for us to look at to compare standard deviation some more, but that's not very resistant. Interquartile range is resistant to outliers. The range is absolutely not. This is extremely affected by outliers because it might only be computed using outliers. And most often, we're going to be using mean and standard deviation. You might think, well, those are sensitive, not resistant to outliers. But one reason they're more often used is they are calculated based on all of the data. Think about the mean, you're adding up every single data point, divide by the sample size. And the standard deviation utilizes every single data point. So all the information is encompassed. The median isn't necessarily using all the data points. You're just cutting the data in half. The range might only be using 2 data points. And same with interquartile range. You ignore the extremities. Okay, so last topic we've already been talking about a little bit, but is a percentile. The p percentile is the value which is greater than p% of the data. And I like to pose this in terms of money. Would you rather be in the 90th percentile or the 10th percentile? 10th percentile or 90th percentile in the distribution of wealth of all Americans? When I think about that, if you're in the 90th percentile, it means you have more wealth than 90% of Americans. Basically, if you're in the 90th percentile, you're rich. If you're in the 10th percentile for wealth, then you have more wealth than only 10% of Americans. And that would be considered poverty right now. So if you had to pick those 2 options, most people would pick the 90th percentile. Now this could be confusing if you're old enough or you remember the 1% movement from a couple years back. that is the 1%. It was talking about the abuses and the issues of the top 1% of Americans in terms of wealth, having too much control and power. But for our stats class, we should be calling that the 99th percentile movement, because it's really the 99th percentile have more wealth than 99% of all Americans. All right, so a lot of times these percentiles are used to standardize exam scores that thousands of people take, like the SAT and ACT, that a lot of four-year colleges require. So look right here. Before we went through the z-score and showed that the SAT is actually higher relative to the mean and standard deviation than the ACT score of 28. But the percentiles also say that. So if you were to get an SAT score of 2100, at least in 2012 when the data was compiled, that would mean you did better on this test than 97% of those that took the test. Whereas on the ACT, if you end up in the 91st percentile, you did better than 91% of people who took the test. So for test scores and money, you want to be in a higher percentile. All right, I mentioned this already, but the 5-number summary, kind of splits up your data in quarters. The min is going to be the 0th percentile. The max is the 100th percentile, because the max is bigger than everything, and the min is bigger than nothing. And the median is the 50th percentile. Q1 is the 25th percentile, and Q3 is the 75th percentile. All right, so we have a histogram below here. This is height. Based on this histogram of heights, estimate the mean, standard deviation, and the 10th percentile. And this is just estimate. We can't get exact values. But for the mean, notice we have a fairly bell-shaped curve, symmetric and unimodal, one hump. So that means the mean is going to be in the middle. So I'd say about 68. So if a distribution is approximately bell-shaped, the mean equals the median, it will be in the center of the distribution. And maybe I shouldn't say equals. They generally want to be the exact same, but they're going to be very, very close. Will be the center of the distribution. That's why here I would say it's about 68 inches tall. All right, how do we get the standard deviation? For that, we need to go back to the 95% rule. And it says we want to estimate two values that will encompass about 95% of the data. So I'd say probably between 60 and 76. Again, this is an estimation. If we take between 60 and 76, that should be about 95% of the data. Using the 95% rule, about 95% of the data lies between, I forgot what I said, 60 and 76. 60 and 76 inches tall. This encompasses 4 standard deviations, 2 above and 2 below the mean. So I'm going to estimate, we don't know exact, but we want to take the difference, 76 minus 60, and then divide by 4, because that should be 4 standard deviations. So that looks like, 16 over 4 is 4. So I'd estimate the standard deviation of this to be about 4. Another way to look is to take that 68, if I go up to 76, that is a difference of 8. You're going up 2 standard deviations, and then from the center to 60, that's going down 8. And the 10th percentile, what we could do here is count up all these values. You want to be very, very precise here. The counts are 2 plus 4 plus 4 plus 12 plus 16. I'm adding up the heights of all these. Plus 20. Let's see, plus 17, let's say. I get an estimate, plus 16. And then down here, where I think we're about at 11, plus 11. And then the bottom two would be back to, looks like 2 again. Plus 2 plus 2. So if I add these up, I'll throw some in the calculator really quick. 2 plus 4 plus 4 plus 12, 16. So I got about 106. And I'm estimating here, so it's about 100. So the 10th percentile will separate the bottom. I'm at it off the screen. So if we have about 100, the 10th percentile will separate the bottom 10% of 106, which is 10 to 11 heights. So what I need to do on this histogram is count till I get to about 10 to, let's see, that's 4, 8. So right around here, the 10th percentile, I'd say, is about 63. 63, 64, somewhere around here. You want to estimate. The 10th percentile is about 63 inches tall, because that separates that bottom 10%. All right, and then we're gonna, in class, look at StatKey. This is gonna be our software of choice. I do have a bunch of StatKey videos I will occasionally link and put up here on Canvas. But actually, the next class, we're gonna be focused around how to use Canvas to get statistics, summary statistics, and look at different graphics. All right, as a very quick summary, we looked at summary statistics for one quantitative variable. So the center was in 2.2, mean and median, spread, standard deviation, range, interquartile range, and percentiles. That 5-number summary is going to be very important. Min, max, Q1, median, and Q3. For visualization, we looked at dot plots, histograms. And lastly, we also looked at symmetric versus skewed and bell-shaped distributions. And we looked at outliers and specifically what statistics are resistant and what are not to outliers. And z-scores. And we're going to come back and study z-scores quite a bit throughout this whole semester. All right, this concludes our Chapter 2.3 video lecture series.